Welcome to my channel. So today I'm going to talk about recursion. So what is recursion in Python? Recursion is a method in which a function calls itself during the process of solving a problem. And this process is called as recursion, and those functions are called as recursive functions. Let me repeat that again. So recursion is a process where a function calls itself during the process of solving a problem. These kind of functions are called recursive functions. Okay. What is a base condition? So each recursion will have a base condition. So base conditions is basically the exit strategy. It's the exit strategy of a function. If base conditions do not exist, the function will return stack overflow error, stack overflow exception. There are no base conditions present in the recursive function. Also, there are few more concepts of direct and indirect recursion. So, whenever a function calls itself directly, it is called as direct recursion, and whenever a function calls in itself using any other function, it is called as indirect recursion. So, mostly while solving a problem, direct recursions are used, and direct recursion are very rare. Okay, now let's come to the memory allocation. So, this is an important part to understand. So the memory allocation is done in stack for recursive functions. Every subsequent call will be stacked on top of the calling method. Okay, and it will have its separate block of variables and separate memory block. Okay, let's demonstrate the recursion with a simple example. Let's see we're trying to print a method which will print the numbers from n to 1 or 0. Okay, let's call this method as recur n and and simply return same function by calling n minus 1. Okay, so this is the normal recursion function where the function is calling itself recursively, but guys, it does not have a base condition. So what we need an exit strategy. Let's say whenever n is less than 1, will return n. Okay, else will it will first print the n, and then it will go on to recursively call the function. Okay, so this is our method. Let's call this with let's say 7. Let's try with 3. Okay, here you go. Here you can see, so this function is calling itself. So recur is the function, and this function, within the function, it is calling itself. Okay, so this is how it is done. Okay, so here you can see, so I printed this and to demonstrate how the calling pattern will be. The first 3 is printed, then 2 is printed, then we are printing. And if you want to reverse the order, let's see if we can reverse it. Let's do this. It's still the same. Oh, okay, yes, because they are called on top of that. 0 will be printed, obviously. Okay, I'll work on it to reverse the order. Probably I need to start from 0, and then I'll have to add the number until we reach a condition of 5 or 6. Okay, so this is all about recursion, guys. So guys, there is one more problem which is solved using the recursion, which is of find the factorial of a number. Let's see how we can solve that problem. So what is a factorial basically? So when I say find the factorial of 3, factorial of 3 will be equal to 3 into 2 into 1. So all the numbers less than and equal to that number multiplied. Okay, let's define a method factorial of n. So again, it will return n into fact of n minus 1, like what we are doing in factorial. What is the formula? That number multiplied by its previous number. Okay, but again we need a base condition. If n is less than 1, what will be the factorial of 1, guys? It will be 1, right? So factorial of 1 will be 1. So let's take this. If n equals to 1, return 1, else return fact of n minus 1. Let's find factorial of 3. Like I said, this is our base condition and this is our recursive condition. Let's run this code. Here you can see 3. Factorial of 3 will be 6. 3 into 2 into 1, which will be 6. Let's take it for 5. You see 125 into 4 into 3 into 2 into 1. So this is how you can find the factorial using the recursion. This is all about recursion, guys. Thank you guys for watching this video. Please like and subscribe.